All right, in this video, we are going to work on another problem from chapter 2. It says, write a program that contains variables for an investment amount, annual interest rate, the number of years, and displays the future investment value using the following formula. Where A is the future amount, P is the amount invested, R is the monthly interest rate, and T is the number in years. Display the results using appropriate text. Okay, so all right, so we're going to start a new program. So start off with the class header, public class. What is it? The future value. Okay. And then the main method header, public static void main string args. Okay, and so that's a good point to compile it. Make sure everything looks good. All right, looks okay. All right, so going through it says that contains variables for an investment amount, annual interest rate, and the number of years. Okay, so amount, rate, and years. All right, so in this formula, the amount you invest is P, right? Here, which another word for that is principal, so I'll use that one, and I believe that is principal, just like the principal of the school. Okay, and just put a number in there. Let's say $10,000, and it should be a type double, right? Because it's dollars and cents. It's gonna be a decimal number. Investment amount, annual interest rate. Okay. So I'm gonna call that rate. Again, your variable names should, have meaningful names. If you just put variables like A, P, or whatever in there, when somebody comes back and looks at that later, especially if you use non-standard letters, they're really not going to have any idea of what you're talking about. Okay, so it's better to have descriptive variable names that somebody sees this variable rate, well then they know almost immediately, right, that they're talking about the rate. Plus, it's easier for you to remember if the code is complicated. You have to look through it. It's easy to remember what rate is. If you just have like R or whatever, you might have to like keep constantly referring back. Okay, what was that again? So it's just easier if you have descriptive variable names to read your own code and for others to read your code as well. All right, and the number of years. So I'm just going to call that years. Let's just make it 25 years. Okay, and so now we need to calculate the future amount. Okay, so according to this formula. So I'm going to declare a variable for that. All right, and then now it's a matter of typing in this formula here. Okay. So again, this is kind of the input part, and then this will be our process part. I'm going to take that and make this calculation. All right, so it's principal. That's what we used for the variable P, principal, times, and then something in parentheses, okay? So, this is a mathematical formula, and so in math, when you have this kind of algebra formula here, you don't have to put the multiplication operator in there, right? It's just not required because it's the fact of being next to one another, juxtaposition, right, is implied multiplication in algebra. So you'll see formulas like this, but in Java, then you are going to have to explicitly put the multiplication operator there. And then it's 1 plus the rate, which we're calling rate, divided by 12 inside parentheses. Good. To the 12 times t power. Okay, so what we're going to have to do, remember Java does not have an exponentiation operator like this. You have to use math.pal. If you haven't watched the previous video on the area of the circle, you probably should go back and watch that, because talk about where that's located in the notes and how it works. Okay, but so basically this is the base, right, and this is the exponent here. And so using math.pal, that would be math.pal. The base goes first inside the parentheses, and that's 1 plus r over 12. And then the exponent goes after a comma. So the exponent here is 12 times the number of years. So that would be 12 times years. Okay. All right, so let's try that and make sure everything's okay. All right, everything is okay so far. All right, and then just to check that that seems reasonable. We can type that out and see that we would have, after 25 years, $18,670. Okay. All right, so that looks like everything's going okay. We'll need to get a better message than this, right? So let's start working on that. So we'll say if whatever amount was invested, which is the principal, right? Principal is invested at a rate of and then rate for however many years. The resulting, or the future amount, is and then whatever the amount there. All right, let's try that and see if it works. Okay, so if $10,000 is invested at a rate of 0.025 for 25, we probably need the word years in here, right? Okay, so that looks better. One thing is that the rate here is given as a decimal. So, when you're talking about things like rate out in the real world, right, there are requirements, right, to federal requirements in the United States about how that rate is specified, right? And so usually it's as an annual percentage rate. So maybe having rate right here is not the best way to do it, as to show it times a decimal. To convert this to a percent, right, what we would do is times that by 100, and you can do that inside here as well. Just do 100 times the rate. and then have parenthesis in there. So let's try that. All right, and so we have a little bit better message there. If $10,000 is invested at a rate of 2.5% for 25 years, the future amount is this amount right here. And we probably need to put a period on the end of that. All right, so we have a pretty good message here. The one not so nice thing is the way that the numbers are displayed, right? That doesn't look good at all. But again, don't worry about that for chapter 2. In chapter 3, we are going to figure out how to use that. It's with something called printf, which is a formatted print. And that is, really the desired way to format these things. And so starting with chapter 3, we'll be displaying these output messages in a totally different way. Okay, that is it on this one.